Okay. So we are on the second part of 8.5. So this is 8.5b. And what we're talking about is we were learning how to identify using a table of values. Which one was exponential? What was quadratic? What was linear? Linear was when we added to y the same amount, plus whatever, to the y values. Exponential was when we multiplied the same value by the y. So like every y value multiplied by 3. Or I could multiply by a half, multiplied by a fourth, and had exponential decay. Quadratic was the hardest one. Quadratic was the hardest one because I didn't see a pattern at the beginning, but then I had to look at the y values and subtract them. So that was stuff like this. I had to subtract the y values and then see what's this pattern here, and I saw, oh, this is plus 4. And this is the part that made it a quadratic. So this is what we did last lesson. Today I'm going to give you pictures and tables of values of graphs, and we're going to talk about, are they linear, are they exponential, or are they quadratic? So here's our first ones. The graph shows population models for 3 cities based on data over a 5-year period. Here it is. Time along the x-axis. 1 year, 2 years, 3 years, 4 years, 5 years. On the y-axis is the population. How many people were there? So, if the populations continue to increase in the same way, when will the population of city C exceed? So when will C be biggest? First of all, let's look at A. A is linear. It's a straight line. The population started at 1 year. So city A. At 1 year, it was at 3 million. Okay? So then this is linear. After 1 year, city B, this is B. B, is that quadratic or exponential, guys? B. What do you think? B is what? No. It has x squared. What does it mean when I have a little 2? X squared. So city B was quadratic. And 1 year, that's the middle line right here, was like not even 1 million. Look at this. If 1 million is 2 boxes, what's half a box? 500,000. 500,000. This is a little below 500,000. What's a little below 500,000? How much thousand is right below 500,000? Sure. 450,000. Why not? This is the population. How many people lived there? C is exponential. And we knew it was exponential because it had this, an exponent with an x. Okay? 1 year. You guys, there was hardly any. What would I call that dot? It's barely above 0. How much? I like 50. Why not? A little, I'll be generous. 50,000 people. But again, we really don't know because it's so small. All right. We compared them. Here we go. When will the population of city C exceed the 2 other cities? When will it get bigger? So I want to let you know that population B is called G of X. It's in the middle of the table of values. Population C is H of X. And just normal A was in pencil. ABC. So this means in 4 years, City A has 12 million people. In 4 years, City B has 4 million people. In 4 years, City C has 500,000 people. Are you getting this 3-column thing? Yeah. So it's like a multi-layered table of values. So year 6, 19 million people versus 9 versus 2. When will City C, look at C only, when will C be bigger than the rest? When? 10 years, 11. 10 years, it's the same as City A. 11 years, City C is 64 million, whereas the other two are only 30 million in City B and 35 million in City C. So we're learning how to read a graph, and we're learning how to read a table of values. After year 10, there it is. After year 10, the population of City C is greater. In year 11, City C has 64 million people. Okay. I could also use a graphing calculator. So I want to show you Desmos. I'm going to turn on Desmos on our screen. I'm going to plot on Desmos all 3 equations. So here we go. You're going to need to be able to do this as well. City A, 3.2x. So I just type in 3.2x. Do you all see this on the upper left corner? Okay. How about that? Is that better? Yeah. Then I just click on number 2 and I can write a second equation. That's going to be City B. 0.25, and I go down to, I need this hidden. Where's my, there we go. Okay, you guys check this out. X squared. I click on where it says A squared. Oh, nope. Oh, darn it. 0.25 x squared. See that parabola? That's City B. City C is, let me get rid of this. This thing is really bothering me. Okay. City C, 8.5 notes. City C, what is it? 2 raised to the power of, check this out. 2, look at this button, A to the B. This means I'm going to make an exponent that's whatever I want. Not squared, but like something to the something. So A raised to the power of B, and it pushes my cursor up to the exponent position, and my equation was x minus 5. I just type that in. Now, I want to know, when will my green, so here's how this works. Y, there we go. I fixed number 1. Now, when will green, wait, what's wrong with green, guys? Look at my equation. What's wrong with green? Look at your paper and look what I typed. What's wrong with green? What's not on the top? The minus 5. So it means I need to put x minus 5 so it all stays up top in parentheses. Okay. When will my green line be more than my red and blue? Here's where 2 of them meet. My green line, look at this. Okay, I clicked on it on purpose. After 10 years, the population will be 32 million. What will it be? We looked at the table of values, it said 11 years. 64 million. 11 years. Look at guys, at 11 years, the population will be 64 million. Look at my ordered pair. But even here, 10.25, that's 10 and a quarter of a year. A quarter of a year is 3 months. Okay, so here's where it exceeds. Anytime after 10 years. Okay, so this is how you use Desmos. We are going to use Desmos in our work today. So I'm basically going to switch back to my paper. On A, B, and C, I want you guys to write samples of what is a linear function. Use any numbers you want. What is exponential? What is quadratic? So make one up on your own. That's your job right now. On the bottom of the page, write a linear function. Y equals something. Write an exponential. Write a quadratic. Okay.
Like this, I'm actually a linear function.
All right. Are you writing them? What are you waiting on? Come on. Make one up. Use any numbers you want. Here's models, samples. Linear just has x to the first power. Quadratic has x squared in it. Any number you want will work in front. Exponential, the exponent is an x. So you get to write down your own. Okay. Can somebody tell me an example of a linear function? Give me a sample. Linear function means x to the first power. Put any number in it you want. Quadratic means x squared. Put any numbers you want. Parabolas. Quadratic. Exponential are like these. Oh, it's not on the board anymore. Well, I need three different people because there's 3 different questions. Straight line. What is it? Y equals 5x. Great. That's linear. Exponential is what? 7x squared. Okay. Give me another linear function. It seems like you guys need to practice what a linear function looks like. Give me another linear. Someone new.
Y equals 5.5x?
Sure. Give me another one without a 5 in it. 4x. Could it be negative 4x? Yeah. Could it have a fraction? 1/2 x? Yep. Okay, give me some more exponentials. Oh, an exponential is not squared. Exponential is what? Exponential is what? Something, no squared. Quadratic is the squared. Okay, give me another exponential. I don't have to use y equals. I could use f of x equals g of x. Yeah. Give me another one. Exponential. We did this exponential growth and decay. Remember growth and decay? 6 squared. No, that would be quadratic. And I have to have an x in it.
How do you pronounce it?
Exponential.
No, like
7 to the power of x. How about, remember this was my y-intercept? And then I could do like decay is my ratio to the x power. Remember we did those? 2 was the y-intercept. 1/2 meant decay. Last one. F of x. Give me another exponential. No means no. Both. F of x equals it's only slow because you're not talking.
Wait, is this quadratic?
Yes. Sure. 4 raised to the power of x minus 6. Great.
Is that how you say it? 4?
4 to the power of x minus 6. All right, quadratic. These are all these parabolas we've been working with. What's quadratic? No 5s and no 7s and no 4s. Give me all new numbers, guys. Decimals, any fraction. 800x squared. Sure. You can even do a parabola. Remember? X squared plus 3x minus 1. Trinomial. That's a parabola. Negative b over 2a is the vertex. Or, Frida. 9.70. Yeah. Sure. Anything. So these are just us making up our own. So you guys know what each one looks like. That's important. Yeah.
So the
Exponential
is the one with x on like above it.
Yep. The exponent is x.
Exponent, and then the quadratic is in the x below, and then like a number.
X squared. X squared.
Okay.
Squared. Power of 2. And it's a parabola. Do you guys remember a quadratic is a parabola? Exponential is like this. Linear is just a straight line. Okay? All right. Turn the page. Your homework is here. You're going to need to get Desmos out. Can you guys all get Desmos out? All right. So, on Desmos, I need you guys to all practice typing these in. Everyone's Chromebook is out? Go to the website, DESMOS. All right. The first one. Type it in. F of x equals 0.55x. Type it in. Start graphing. Let's start graphing.
Oh shit!
Is it blank? All right. Yeah. I'll have to type because I'm recording. All right. Type it in. 0.55, 0.55, and then you just type with your keyboard an X. Got it? I'm not waiting for slow people. Let's go. Second one, click on the number 2 line in Desmos. So it gives you a clean, empty cursor. 0.0023. Now, ready? You have to click on this little keyboard button down here. Everybody see this?
Yes.
And that's how you get to the x to the squared. So click on the little keyboard on the lower left. X, and then you click on a squared. And that gives you the little exponent of 2. Right here? 0.023x squared. Everybody got it? Okay, next. Third one. All right. 1.4. Click on a raised to the power b. This button. And then you type in x in the exponent position.
Miss Grant, does it matter if it's the A2 or the A3?
Yeah. Squared is just the h squared. This is any number raised to any power. This is only squared. Then I'm going to put the arrow over once. Like on your keyboard, arrow, right arrow. To get down to the normal level. And then you put -3. So I don't want the -3 to be with the exponent. I want the -3 to be big with the... Are we all clear? Now, this is exactly what your piece of paper looks like. True? Does your piece of paper match your screen? I need to zoom out big time. You can move the keyboard down by hiding the keypad like here. Arrow, zoom out, -sign. So there we go. Now, it's asking you on your piece of paper. Ready? When x equals 2. When x equals 2. Part A, evaluate each function for x equals 2. Slide your mouse along the x-axis and go to 2. When x equals 2, what am I at? Like, where's my first equation? So look at this. When x equals 2, right here. You guys have your computer screen. I have to put this up. H of x, f of x is what? This is f of x, straight line, is what? What number is this approximately? Why don't you click on it on your mouse, please? What is this point right here? When x equals 2, how high do I have to go to get to the straight line? Look at your computer screen. Put your mouse on the straight line. At 2. 2 comma what? What's the order pair, guys? What's the order pair? Are you clicking on it like this? Did you look at it? Did you all get 1.1? Do you understand what I'm doing? If x is 2, what is y? 1.1. So I wrote, I know this is taking a while, that the f of x equals 1.1. Y was 1.1. How about on h of x? Or what's next? Oh, sorry, g of x. Right here. Can you please click on g on your computer screen? 2 comma what? What is my ordered pair? Blue. No, this one. The blue. When x is 2, what's that? 2 comma what? Approximately, what is it? 2 comma what? On your blue line, guys. Your blue line. Point what? What is it? There's only one person looking at the screen.
No, she's helping.
You should watch what she's doing so you know how to do it. 2 comma what? What's my blue line, guys? 0 point what? 09? 0.09? What's the deal, guys? Why is this? Come on. It's here. 2 comma 0 point. Are you getting this? Yeah? Everybody. 0.092. What about the h of x? Go to 2 on the, what color is it? The third line, you guys? Green. Go down to green. What's this? Negative 1.04. Okay. Please click on it so you guys know how to find these. Because I just modeled x equals 2 for you. You have to do x equals 4.
I didn't do it.
And you have to do x equals 6. So go over to 4. It's my red line. Go over to 4. Tell me what each line is at for the y value. You zoom in and you click on it with your finger. Or no, it's first. Never mind. All right. I'm going to stop the video. You guys are responsible for doing 4 and 6 and then answering part B. That is your homework right now.